about these positive externalities. Thank you.
So good morning, and thank you for inviting me here today. So my name is Lisa Baldi. I'm a researcher at the University of Parma, and today I represent the AGRICORE project. So in my presentation, I want to give you an overall understanding of what the AGRICORE project is, what it is, how it is structured, and what are the specific innovations that we introduce compared to the current state of the art. And hence, I will describe the AGRICORE modeling approach and the tools that we have developed in order to provide an enhancement for agricultural policy assessment and potential future definition. But as I said, I'm only the representative of one of the partners, so I'm more familiar with certain aspects than others. So I hope I can still answer your question, whatever comes on the floor later on. So, as I said, I would like to start with a brief introduction of the project. Then I will dive into the modeling approach. And I will conclude with the final step that we still have to do before the end of the project. AGRICORE, the scope of AGRICORE. The scope of AGRICORE is to introduce an innovative tool that is designed to enhance the ability to simulate and to analyze the agricultural policies. So this development obviously is based on advanced modeling technique and on ICT capabilities. It is obviously composed by a consortium, so the AGRICORE consortium counts 10 partners. That goes from Spain. We have 3 partners in Spain. We have a couple in Italy. We have 1 in Germany, 2 in Poland, 1 in Greece and 1 in Turkey. And it's also a very diverse team because we have academia, but we also have IT consulting firm, and we have a cooperative of agriculture, of farmers, and so on. So the AGRICORE project, as I said, proposes a series of tools built adopting an agent-based approach where each farm is modeled as an autonomous decision-making entity which individually assesses its own context and makes decisions on the basis of its current situation and expectation. So the main concept of this project are an advanced population concept, an agent-based model, and a user-friendly interface. These are the 3 main advancements compared to the state of the art as of today. And then if I have to contextualize the work of AGRICORE compared to BestMap and MindStep, to summarize it, I would say that from one side, BestMap is more working on empirical data and interviews and using those data into different agent-based models, whereas MindStep is using current and well-established models and trying to compare and try to put together data and enhance the characterization of the single farms. What we actually do, as I said, we just provide a tool where all this information can eventually be reused and collected. So there is a sort of synergies between the different projects. So the architecture, at a glance, the architecture of AGRICORE, in order to simplify it, we have identified 11 building blocks. So, and these building blocks are divided on, they are mapped to the 3 points that we saw earlier in the previous slides. So as far as the advanced population concept is concerned, we have, to start with, we have the data source and identification usage. And for that, in this D1 block, we have developed a self-standing tool, which is called the Agricultural Research Data Index tool, ARDIT, which is in fact a platform that is suitable to identify data sources that are indeed needed for the analysis and that can also be used beyond AGRICORE. So it is a module that is connected to the entire AGRICORE model, but it can also be used as a self-standing model. Then we have the data warehouse, which is the central point where we collect all the data that are needed for the simulation. And then we have from D3 to D5, we have a set of modules that allow to extract big data and to transform this data into a synthetic population. So this is one of the advancements I was referring earlier. So what does it do? We take existing data that can be from census data or sample data, and through intelligent agents mechanism, we create a similar population which is upscaled to the level of the region, or mostly on the region now too. And this population is actually statistically representative to the of the reality. But through this mechanism, we actually overcome the data protection regulation. Then as far as the agent-based model is concerned, as I said, we have developed a core, which is the agent-based model simulation module. In here, I will explain it a little bit further, more in detail, what it is all about. But what is important to notice is that this module is connected through an interface to external modules, some from the project and some that can actually be outside of the project, but we name, for instance, we have an interface with the biophysical model, we have an interface with a land market module, and we have an interface with the policy environmental module that you see there on D10. And on top of that, this interface also linked to the impact assessment module. So at the end of the stream, we have developed 3 specific impact assessment modules to assess impact on the environment and on socioeconomic parameters, KPIs. And then in the end, we have a an AGRICORE user interface module. I wanted to make a little demo, but we are not connected to internet, so that will not happen today. So to move on a little bit more into the modeling approach. Okay, we start here. So what do we have? As I said, advanced population concept, that's the first thing. We have to, first of all, identify the data source that we need for the research. So this is the first step. And we do have some questions related to that, obviously. So we need to know what are the databases that we need to use for developing our scenarios. Then how can I get access to those data, and how can I get those data into my scenario, into my modeling stream? So we try to answer to those questions, as I said earlier, with D1, which is our RD tool. RD tool, as I said, it's an index tool. So in there, we had already characterized almost 400 data sets. So if you go and search on specific variable, for instance, you can find which data set contained that information. However, the message here is that we should start using this tool, because the more data set you characterize, obviously, the more information you have in there, and the more useful it becomes to the researchers. And then, of course, as part of the project, we also have developed this other interface that allows to immediately shuffle the data that you get from the data set that you find through RDIT into the data warehouse to later on publish produce the synthetic population. This is how the RDIT tool looks today. So it is available, publicly available. You need to request for a sign-in, and then in there, as I said, you can have different information on the data sets. Then, We move on to the construction of the synthetic population. As I mentioned earlier, we can use census-like data or sample data. We mix them all together, we put them in the data warehouse, and then we extract them, and we create the synthetic population. The population, as I said, represent an evolution of the currency policy impact assessment approach, because obviously normally either we use existing data, census data, and often we have troubles because these data are protected, and so on and so forth. So the advantages here is that you first have it automated. Secondly, you remain the constraints of the personal data, and of course you can reuse this set of data for several simulations. And of course you can scale up. Then, as far as what happens next, so what do we do with the synthetic population? We actually need it for two purposes. First purpose is to create the information at the level of the population, and we use that to calibrate the model, as well as to set a baseline for our KPIs analysis. But we also use that information to instantiate every single agent that we use in the sample. What does that mean? It means that we have every single little agent with different characteristics, from the production, from prices, from family structure, and so on and so forth. So in our model, every agent represents a farm holder. And all this information then, of course, are used to calibrate the model. And then we move to the core of the entire project, which is the ABM model. How does that work? So there we have, as I said, agents, which represent farm holder or the farm. And every agent is an individual that triggers individual decision. And how does it do that? It does it based on status, knowledge, and forecast. What does that mean? It means that he's going to make decision in the long run based on the production that he's using in the farm, about the environment he lives in, and the forecast that he may have in terms of prices, in terms of weather forecast. When I say in terms of knowledge, what do I mean? I mean that within the model we configure latent technologies. So you have different agro-management practices that are configured. And if I'm a farmer that today is cultivating with a conventional agroeconomic practice, I know that my neighbor is doing organic, and eventually if I have an economical convenience, I can swap and go to organic farming. So when I know all this, I do my own assessment as a farmer. And then I do an assessment in the long run that foresee, or may or not foresee, the purchase of land. So that's why we have that interlink with the land market module. So if it is, if I have enough cash flow, and if it's economically convenient for me to buy extra land, I'll do so. Then in this context, there is policy scenarios that obviously can be configured, can be a subsidy, can be a tax, whatever. And then here, the long-term objectives that the farmers have set are used as boundaries for decision at the short period framework, which is basically the yearly the run of the campaign on a yearly basis. So during this short-term simulation, we take into account marginal cost per crop, we take into account decisions such as in short-term rent in or rent out land to increase revenues and so on and so forth. This can still be reviewed in terms of what are the actual weather forecast, or if it's a dry year, if there's any price shock and so on. And this information can come from other models, and then we realize the campaign, so we do the simulation, and we have a new status of the farm. What happens next is that this is a reiterated flow, so farmer goes from the estimation of its status, the decision, the realization, and this is happening for a certain amount of years, which is configurable. We normally consider 4 to 7 years, and then at the end of every single year, we use the data of one simulation of 1 year is used as a baseline for the simulation of the next year. And all this ends with a certain amount of years that remain into the boundaries of the long-term planning and produces results that are checked against initial KPIs through the interface. So this is the landing page of the friendly user interface that we have developed. Unfortunately, I cannot walk you through as mentioned. However, here you have steps like the simulation setup that will allow you to generate the famous synthetic population that I explained earlier, using data coming directly from RDIT, if you want, or you can use any other type of data. Then you create your synthetic population, which you will use in the simulation, and then you have a visualization tab where we have information on things such as the production at the regional level, the organic surface produced at the regional level, the land allocation in terms of crops, and that can be visualized at the regional level, but on a yearly basis. So you can see the fluctuation or the evolution of the population throughout the years. So I'm getting close to the end. So what is left compared to the other cluster project? We are getting a little bit a longer extension. So we are now concluding the project officially at the end of May, although the development will finish at the end of this month. So by the end of this month, we will complete the debugging of the flow, short period, long period, that is already working. And we will do the final integration of the remaining modules, which are the impact assessment modules. And we will do the testing of the complete flow. And then in March through May, we will do dissemination. We will do the configuration of the use cases that we have developed in the project. And we will obviously get to the end of it. Just one extra slide to summarize briefly the use cases that we have developed in the context of this project. So we have 4 use cases. One, it's on the Andalusian olive trees conversion to organic farming. One, it is in Poland, is also an acceptance of the agro-management schemes for climate mitigation, climate commitments. And then we have in Macedonia a use case to see how farmers react to the subsidies for new establishments, so in favor of young farmers. And in Italy, we have done a scenario where in Emilia-Romagna, we adopt the taxes on CO2 equivalent to see how this impact the production and the land allocation, and especially the impact on the livestock production. So this is it. So to conclude, I just wanted to again confirm that this project complements, in my opinion, the other project very nicely, and it makes sense. But I think that now we have to find a way to make sure that there is again a continuation to this project, to this effort, to make sure that this tool can be actually used and developed and improved over time. So that's it.
Thank you very much. I think now it's time for question. Maybe again I can make the first one to break the ice. You will say that this project is complement to the other one. I mean, we already started a discussion yesterday about that. What kind of synergies do you think AGRICORE could offer to the other two projects?
Okay, so as I hopefully explained today, AGRICORE, I'm not going to say it's a prototype because it is in fact an application that it's working, but it requires and it's made for welcoming further scenarios definition, further enhancement. So all the effort that has been done by the other projects and the results that are coming out from the other project can definitely be used in order to parameterize the elements and the variables that we have into the tool already, or even enlarge the spectrum. And so I think that as the other ones are more proposing like a methodology or an integration between different model and data sets, here I think what we can do is provide really the toolbox to use this information and also to somehow, from one end, simplify the readiness of the results, which is always very critical, and at the same time reach a level of sophistication in terms of agent and heterogeneity that is not to be neglected. So I didn't go very much into details in terms of how the agent is defined, but we can, through certain rules, for instance, I was referring to the family composition. So one of the rules that we implemented in order to allow farmers to go from conventional agriculture to organic agriculture, we set the rule and we say if the farmer is over 65 and don't have offspring, he might not go for a total change in the farm, so it might not convert to organic farming. So that is already an example of a behavioral rule that is simple enough to be implemented in a technical environment.
Thank you. I think we have a question.
Here I am.
Sorry, take a big hand.
Thank you, Mr. Chairman. Good morning, citizens. I have a comment, not a question. We have to use the name Northern Macedonia because we have South Macedonia. We have Macedonians also in Eastern Macedonia.
Okay.
It's in Bulgaria. So in order all of us to be happy and to follow the laws, as Europeans should do, we should name it Northern Macedonia. Thank you very much.
Okay, thank you very much
Important
for the
comment.
clarification, and I'm sorry. Yes, it was in Greece.
Typical
Sorry.
disclaimer. I have a Greek and a North Macedonian in my team. It's complicated. Thanks a lot, Lisa, for the presentation. I just have one practical question. You talk about, so I see this still as a prototype because I didn't see any results, which I assume they are coming. And I would like to ask you about this synthetic population. I mean, how, because in the end, I mean, you saw the case of BaseMap and MyStep. We tend to feed our models with Eurostat data, FAOstat data, data sources that can be maintained over time. So I'm just missing a little bit the link between this synthetic population and this calibration. Where do actual data come in? And how did you survey it or got the information about the behavioral component? Because how did you, I mean, did you ask farmers? How do you know how farmers will react to certain changes in this environment that you mentioned? Thanks.
So currently what we are using is mostly the FADN data. So for the prototype phase where we configure these 4 use case scenarios, we mostly use FADN data, and that is, I mean, the concept behind, as I explained, if you take, I take the example of Emilia-Romagna because that's the one I know the best. So you have 800 farms that are surveyed, but in fact they represent 35,000 farms in Emilia-Romagna. So what you do, you take these 800, you put them into this, they first go into the data warehouse, and then they are extracted and manipulated Again, I'm not going into the technical details because I don't know them, but I know that they use some sort of intelligent agents and probabilistic approach in order to say, okay, if there are 35,000 farms in Emilia-Romagna and in the sample 5% of them are below a certain surface class, then you just upscale that 5% to 35% and you have so that's how it works, basically. But then again, it was not the UniPR developing that specific module, so I get what comes in and what gets out.
Okay, so another question?
We have one.
Okay.
Hi, Lieke Brakkel, now working for the Dutch Ministry of Agriculture, before at Delft University of Technology as a researcher. And my question is a bit to all three projects using agent-based modeling in many ways, because it's a sophisticated tool trying to get human behavior, and how I got it explained from colleagues at Delft, is that it's a way also, the outcome is an experiment, right? So you put in behavior rules, and then you get these patterns because of all what you described. But then what comes out of it is maybe some new patterns that we cannot see. But it's but in a way, it's not prediction. So I'm looking a bit in where is this policy support and where is it maybe informing it, because it's not prediction. And maybe in policy support, we need more information on how to make monitoring more cheaper and easier instead of very sophisticated. So where's the added value beyond what we already know from survey data or interviews? So this is not against your project, but more in general, the agent-based modeling as a method.
Well, thank you for the question. I think there are a few different point of view to look at it. So, well, first of all, I would say that this modeling approach can be applied to forecast, but also to be used as a ex post. So with that system, you can, of course, at least validate the effectiveness of the model. However, what we need, it's a sort of a prediction is probably not the correct word, but indeed, if you have complex rules somewhere, somehow, that allow you to simplify the impact that a tax or a subsidy could have in an entire population, that could help in, let's say, placing the money at the right spot. And I understand that these ABM models are fairly sophisticated, but that it is actually needed if you really want to go drill down and move away from a decouple subsidies approach towards something where you really want to put the money where they're needed. And so you have to go more into details, and this type of policies have to actually go down on the field and see what to do with it. And then the last thing I wanted to say, and now I forgot it. Okay, so I hope that answers your question somehow.
And how do we get it cheaper? Anyone with a daring question?
There is another one.
Yes, thank you very much, Lisa, for the interesting presentation. You said that soon it's a platform, it's something user-friendly for maybe also a farmer to see what could be his possible scenarios for the future. There, of course, the question arises of maintaining such platforms and to keep them on with, let's say, evolving policies which change sometimes from one day to the other, if just to mention yesterday. So there is a challenge of keeping such models running for the next decade or for the next policy, to make them also, let's say, applied by the decision makers in the member states. And to see how could they use that? What are your comments on that? Thanks a lot.
My comment on that is that indeed the approach that we want to do in terms of dissemination of this result is really to have perhaps not like large-scale conference on presenting the tool, but try to have smaller group of policymakers or at least stakeholders and potential tool users to give us feedback. But then, of course, we need to find the funding for upcoming work. But that, in my opinion, maybe thinking a bit in a smaller size, but it could come out if we manage to be, let's say, sexy enough to sell this product to policymakers, even at the local level, who could eventually support some specific studies, and that will help us in order to enhance some parts, some bits and pieces of the project. So indeed, like for instance, as I was saying for RDIT, now we should, all the time that we want to make a specific analysis, keep on characterizing into the tool those data sets that we need so that it can refresh the data that are in there. And then same story for the rules that define the policies, the rules that define the type of characteristics of the agents that we want to test. So the only thing to keep it alive is to count on the fact that one of the partners is an IT consulting firm who is probably going to hopefully use and sell this product somehow, not the product as such, but the consulting services that are related to that same story. Even if we are working at the university, we are called in to give some advice here and there, and that can provide resources to keep it alive, but it's definitely our hope to keep on going. Yeah.